What would you do if you got a ticket like this? Now, in the industry, I've actually had a ticket which has been very similar to this sort of thing. Very, very similar. It's for a branch office in which I connected through to the data center. Now, apologies for my voice today. It's because I've had a bit of a cold and been coughing, and my throat's a little bit up and down, so I'm taking medication for it, but I still haven't quite got there yet. That's why it's a bit raspy today. But no worry, I've got the gain on my mic set, so you should be able to hear everything anyway. Right. So what's the first thing I'm thinking about in this sort of context? Well, the first thing I'm thinking about is my network. What is my IP addressing going to be? Why? Why is that? Because I specifically know that 68 people minimum is going to be connecting to my network. Now, I split across 4 departments. Yeah? Across 4 departments. But I also know I need extra capacity. The key word here is extra. Right? Why is that? Because it's a good networking practice to have extra capacity anywhere in our design. Right? And what are the key business benefits for this? Well, it means it's less maintenance, it's easier to service. What else can we think of? It means that we don't have to create other additional subnets, right, for the same engineering struggle. There's CAPEX as a result. What does CAPEX mean? For those of you who are non-business, what that means is capital expenditure. We're not spending more on switches and extra IP addressing, right, provisioning, because we don't need to. We can use the existing equipment, and that leads us on to things like router on a stick, right? Because router on a stick, with the amount of bandwidth required, is perfectly capable of delivering 68 people. And how do we know this? We know that from Class C implementations. That happen every day. Think, for example, about your modem, right? Your modem router, if you're on modem router. Think about pfSense, right? Whereby you have 256 IP addresses. How do we get 256? Well, within that class 3 and the /24, it's subnetted. Yeah? It's subnetted to 24-bit addressing. And therefore, with that 24-bit addressing, we have 8 bits which are spare, which is our subnet bits. 24 bits being the host bits. 2 to the power of 8 gives us 256 minus 2. Why minus 2? Because 1 is the network and 1 is the broadcast. Meaning, within the network we have 254 IP addresses which are usable. Yeah? So at 254 IP addresses which are usable, that gives us plenty of capacity. In this case, we don't even need to go down that far. Why? Because we can have 128 IP addresses which are usable. So we can go to /25. It makes it very easy then for us to understand the mechanics of how our network is going to be built as a result. And within 4 minutes, we've actually designed most of the network without actually doing anything. The point of this exercise that I'm trying to put across is that it doesn't matter if you're in DevOps, networking, network automation. The point is that we're constantly thinking about, okay, well, what if we do one particular thing, what does it mean? Why are we doing it? What is the business need? How do we explain this to our managers? And by being systemic in the way that we do things in our approach, what that allows us to do fundamentally is that allows us to make a better business case that we can put forward to the people who are non-technical. These are the managers. These are CEOs. These are founders within the business who don't have the same level of engineering interest that somebody like us would do. And that is the reason why we have to be quite systemic. Now, this would actually be part of a bigger task inside of an epic, or even a story. Generally, this would be a task within something like Jira. Why is Jira used? For this exact purpose, to monitor the progress of what's being captured for a requirement. Now, if you go further into this, this will be non-functional and functional requirements. Functional requirements are what's absolutely necessary. Non-functional is what, okay, we can have a bit of flexibility as to whether or not we implement or not. Now, generally speaking, in the agile world, we'd have story points. Some particular managers will have things like burn down charts, for example, as two very common methods within Scrum or Agile methodologies that are used to track progress across the entire team. Moving on to the network implementation, well, let's jot what we just talked about down. What do we know? Well, it's going to be a /25 IP address range. Why? Because it gives us the increment as 128 bits, 128 hosts, right, per network subnet. Now, why do I say network subnet? Because the actual network IP address starts from 0 and it ends at 128 on the last octet. Yeah, the last octet. What is that? Well, in an IP address we have 32 bits. Therefore, if you minus 25, that gives us 7 bits left to play with, and that last 7 bits is at the end. So what does that look like? Well, consider this, right? 25 bits, right? 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. That's 16. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. Which is 24, 25. Okay. 1, 2, 3, 4, 5, 6, 7. Yeah. And that's where we go from, right? Our increment will always be on the last one, the last significant bit, essentially. That's called. So this is the 1, and we do our subnet calculations through that last significant bit. So how would we implement this? I would say, okay, well, it's a relatively small firm, therefore something like a 2901 would be absolutely suitable. It's over 10 years old, fairly inexpensive. CAPEX means the capital expenditure which is necessary for the purchase of the investment is going to be somewhere in the order of around, maybe, I would say somewhere between 100 and 1,000 pounds, which is absolutely fine for what we're building here. Okay, so that's good. So what should we do? Well, we can fast forward this because we're in packet trace, and the real thing, it would take longer to boot up from the flash memory, right? Because your iOS is stored within the flash directory. Apologies, my voice is going, so I'm going to take a sip of water. Right. Hopefully that has sorted out a little bit of the voice problem that I'm having. Because I'm sounding like a mouse right now. It's not because I want to, it's just because I can't talk that well. I'm going to take another sip of water. Okay, right. You know what, let me try and talk like this. Maybe it'll be a bit better. Right, so the first thing we want to do, right, is think about security. Why do we think about security when we build anything? Whether it be an application, a DevOps pipeline, or even a network automation. Because if we don't build fundamentally with security, what it means is that it opens us up to a lot of loopholes. Now, there's no such thing as perfect security. It doesn't matter if you work with Palo Alto, it doesn't matter if you work with Juniper, Cisco, it doesn't matter if you work with CI/CD platforms like GitHub Actions, Jenkins, for example, Drone, if you're into that kind of space, right? There's no such thing as 100% security. And we've just seen, not just a couple of months ago, I actually have a video on my LinkedIn which talks to founders in more detail around things like the NPM supply chain attacks, which have been happening recently, which is very much used in Vercel, right? Because Vercel has a lot of impact on NPM type packages, yeah? So there's that, right? So, in terms of security, what are the things that we can do? Well, let's make a list. Let's find out what exactly can we do. So we do basic, so we can do basic security, right? SSH access. Now, here's the thing with SSH access, right? And we'll come back to this, right? It's called public and private key. What else can we do? We can do what's called a router on a stick. Why do we want to do router on a stick? Because it saves bandwidth, right? Bandwidth, and it's easier. It's actually easier to implement. Yeah, it's easier to implement. Why is it easier to implement? Because we only have to deal with one interface. Now we could go down the other route and say, well, okay, we have 4 departments, so who cares, right? We don't have to necessarily worry about bandwidth constraints. But think about the amount of packets going through per second. right? It's a lot of information at any one time, depending on the flow of the switch. Now, is that a good thing or a bad thing? Well, the trade-off to this is that we don't have to do with bandwidth contention. Now, it should be noted that bandwidth is not the same as throughput. Bandwidth is the capacity. If you think about a highway, right, a highway can be split into lanes. Now, you can have a 6-lane highway, a 12-lane highway, and that's essentially what we're doing with router on a stick. With router on a stick, what we're doing is we're saying the amount of available lanes that we have, right, in relation to the pipe, right, which in our case could be 1 gig, 2 gig, 10 gig, 100 gig, is split amongst the number of VLANs that we select. So what does that mean in terms of VLANs? It means that we're segmenting the network so that way it's not easily accessible from different parts of the network until we have a router in the middle, which does something called inter-VLAN routing, which is basically like it's a bit like having a toll booth and saying, one is for trucks, one is for cars, one is for motorbikes, that kind of thing. And when we think about it that way, it's easier to segment the traffic into where it needs to go because each part of the information which goes through the network, right, which in this case would be a highway, is tagged or untagged, right? Tagged or untagged. So in other words, like if it's tagged, what it means is it has to go through like, if maybe you're in Asia. So if you're in Asia, you'll have something like the expressway, right, which goes directly over the highway, but like, there's nobody on the lane. It's a bit like a toll, but it's like, the super fast version. Like that. And then there's other ones, which is like, okay, rather than it being the expressway, right, you have to go through the normal highway and there's more traffic, there's more things, less benefits. It doesn't necessarily mean that that is a good thing about tagged and untagged. All it means is that there are different ways of being operational with it. Therefore, we have to be careful in the way that the implementation is done. Okay, great. So bandwidth, right? Bandwidth, we can say we tag the information. Tagging up information on VLANs. Okay, which is all great. And then what can we do there? But we have 4 departments. Now, 4 departments means that we have 4 different switches. Now, why do I say we have 4 different switches? 6 to 8 people. No, we have more than that. I do apologize. We have 2 switches per department, which means that we have 8 switches. Now, why do I say 8 switches? Because the maximum density, right, we have to take into account density per switch at this point. Now, density per switch, as far as I'm aware, it can go up to 100 ports, absolutely. But let's think about this. It's a small office. Is there really a good trade-off to having one switch with 100 ports? Is there a really... I apologize. Is there really a significant trade-off to having a switch with 100 ports at a layer 3, for example, right? Because it would be a layer 3 switch, as opposed to having a layer 2 switch and then saying, right, okay, why don't we purchase more, an older model, which would be cheaper, but we can have, 24 or 48 ports per switch, as opposed to one at 100, So that depends on the cost bracket at that point. The cost bracket would dictate the decision as to whether or not we should go with that. I would go on if I was to do this in real life, I would go on, well, what do we get in terms of functionality versus what we get in terms of cost. Now, when I did a project like this was done via my procurement manager. My procurement manager would tell me, right, okay, this is the amount that we need to spend. In my case, it was £1,000 for a very similar system. And they would turn around and say, right, okay, here's the firewall rules. So ACLs would be a thing. Do we need extended? Right, because it's a Cisco system. Or do we need to have standard? So those are the things that I'd be thinking about straight away. Okay, well, who needs access to what? Why do they need access? Do they need access back to the data center, for example? Do they need access to something which is on a head office, right? Now, VPNs come into play here as well. Now, for the simplicity of this particular project, it's a little bit vague. So one thing that we could ask is, well, are these four departments in the same place? In the same vicinity, right? Because let's think about it like, AWS, right? We have multiple regions, for example, within a VPC, but these regions could be geographically separate. What that means is, for example, like I could be in England, but my data centers are located across England. So I could be in Manchester, for example. I could have one in London, right? So let's say it's Telehouse, for example, and that's, because they're one of the data center providers, but, they have physical geographical locations throughout the world, I believe Telehouse does. But there could be one in Manchester, one in London, and then one in Scotland, for example, right? They're in the same country, they're just geographically in different regions, right? In different geographical spaces. And usually there's three, and that's redundancy purposes. Notice what I did there by going into that explanation. And now we're seeing the architecture. Well, hold on a minute. I've only got one router on a stick. Is that really the best use of capital expenditure? What happens if the router goes down? What happens if you don't get the network back up? What happens if the internet doesn't go through? And now we're thinking, what are the trade-offs? What are the benefits of doing the system this way? Yeah. So those are the things that you want to be asking, right? And I've kept this vague on purpose to give you that idea of, well, okay, what should we be thinking about when we do engineering? What are the things that we are thinking about when we do application engineering? It's not good enough to turn around and say, this is for my business. Oh, I can make something in 2 weeks, blah, 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 blah. I use AI to do this sort of stuff. And did you think about all of this stuff? Did you think about the level of questioning that you need to go back and ask the person for the application? Did you actually communicate with the person, the relevant people? Did you communicate with the team to find out even more of what needs to be done? Because if the answer is no, then it doesn't matter what you bring to the table in terms of the solution will never become what the client or the customer wants, or even the manager, or even your team players that are with you building the application. Because the problem is not technical acuity or even management. The problem just becomes communication. And this is something that happens quite a lot in networking and even in networking. I mean, I did both, right? My position was both for one company. So I had to play both fields. I actually loved it when I did that. It was really, really nice because I got on-prem, I got cloud. I was doing the whole thing. It was great. A lot of the people said it was too much firefighting. I disagree. I thought it was fantastic. Especially for an SME, a small company, it's great. It's lovely. But anyway, so here we go. VPN access. Do we need it? Is it needed? Right. What about BGP? Do we need BGP? I would say it depends on where it's going. So in this case, I just said, well, we've got 4 departments. Okay. Well, maybe we don't need BGP in this place, right? There's nothing to say that. Plug it in and it just works. So I think for now, this is a pretty good chunk of information, right? And I think for now that kind of works. Now, what I would say though is VTP. Is VTP? I would say yes, and we do need something like redundancy. Why do we need redundancy? Now, VTP falls into this very, very well because the VLAN database gets transferred between all of the different switches which are inside of the network. That is fantastic. Why? Because it means that when we add the VLAN back into what's called the master switch, the clients will definitely get them because you can't really mess with the clients. There's nothing you can mess around with. But the only one that becomes a bit of a problem is transparent. Now, when the switch is in transparent mode, you can make local changes to the switch, but they aren't necessarily propagated towards all the other switches on the network. So I wouldn't recommend doing transparency mode. So what I would do is a master client system. Okay, and that allows us to have redundancy because it's multiple switches in the system, like we already talked about, right? Because we're not going to have 64 ports available on any one switch, or even 68 for that matter. But we need to accommodate for that particular subnet size. Okay, so we already know our subnet size is going to be 25, right? Okay, it's going to be /25, right? And we know that there's going to be 4 departments. So 4 departments is 4 subnets. Yeah. And so if we make 4 different subnets on any of the IP addresses of our choosing, right, it makes more sense. Now, here's the thing. If we're using a VPN, if we're using BGP, generally speaking, we should be using a public IP address. If there is a requirement for it, but in this case it says there isn't. So the trade-off would be, well, we probably don't need it then. But I would be conscious of having another router, right? Another router. Simply because, right, there is a problem whereby if the router that I'm doing with router on a stick becomes non-functional, the entire network would go to a standstill. So that's what I would be thinking as well. Okay, have another router, and the reason why is, we have a redundancy. Redundancy can come through, and that could be through the use of OSPF, something of that nature is what I'm thinking, and then have the well, actually it wouldn't be. It'd be VRRP actually. It'll be a VRRP type protocol. So we want like a virtual redundancy protocol essentially. And basically what you want to do is you want to have that virtual IP address. That virtual IP address then becomes what we would point on the subnet to which router becomes the um, preempted version of uh, the active and the standby router. So whoever becomes active, the one becomes standby. Now there is a particular protocol for this, and I forgot which one it is. I think it's HSRP. HSRP would definitely be something I'd be looking into, which is hot standby redundancy. And then by having the two, I would set the subnet of the virtual gateway, which is the VIP, the virtual IP address, down to well, if it's the gateway, oh, that's interesting. If it's the gateway, I might set it to the default gateway IP address on DHCP because that's the one that makes sense on every single subnet. But it is something that I need to work on because it's one of the areas which is a little bit tricky to do. But yeah, it is something that needs to be looked at. So HSRP. It's a little bit more of an advanced topic, but it's a good one to have a look at. But yeah, it's something we should be thinking about anyway. And is there anything else? Well, the IP addressing, isn't it? So it's going to be IP addressing. And I would say for a network of this size, a private IP address is probably preferred. So I would go with something of a class C because I already know, it's going to be in the 16 range, right? It's normally on the RFC 1918. I believe that's correct for RFC 1918. So this is stuff about Palo Alto, pretty cool stuff. RFC 1918, I'm fairly sure class C's on a 12 or a 16 on here. I'll double check. And there we go. Yeah, it's a 16 prefix. There we go. 192 is on 16. First of all, it was a 24-bit block, 16, yeah, that's fine. Right, and then for a Class C network, right, it's a third block, 256 contiguous Class C network numbers. Yeah, so it's subnetted already, is what I'm trying to say there. Okay, and that goes back to networking theory. So that's what I would be thinking about, right? And if I follow RFC 1918 rules, then it's going to be 192.168, and then be my subnet number, which could be 1.0, and then, slash 2025 in that case. For one network, I think I'll keep them relatively distinct. So I would say, let's keep that 192.168.2.0 slash 25. We'll do 192.168 3.0 slash 25, and then I'll do 4.0 slash 25. Now, why would I do that? Now, by doing that, I've allowed myself to have VLANs. I've allowed myself to then split out the network and then say, right, if I'm going to be designing this network and it needs to be distinct because they're different departments, the IP addressing is not going to interfere with each other, and there's enough space in each one of the IP addresses for it to be independent, but also to be reachable in the event that each department needs something from the other one. Right? Marketing might need something from sales, or engineering, for example, right? Because if it's a car, that's exactly what I'd be thinking. Marketing needs to have something from sales. Engineering probably needs access to a NAS system somewhere. Manufacturing needs access to engineering, probably for a VoIP system, and therefore having the right amount of IP addresses is absolutely tantamount. Yeah. But knowing that, okay, the company plans to expand, to having more staff, now, albeit probably not 128, probably be more, but having the capacity to do so means that we don't spend that much money in the short term, but we can build up the business case to say, right, look, it will work, basically, without wasting too many IP addresses, right? Because it said 68 people in the short term. Okay, cool. We could, if you wanted to, go up to 256 if you wanted to, and maybe that's a good idea, going to /24 in that case, because we get more, and we don't have to do a lot more of the subnetting. But it does mean that we end up with a lot more chatter on the network. So you have to be a bit careful with that one, because it's a trade-off. Can the network handle it? Yeah, most likely. It just depends on what type of chatter we're putting through it. Because we don't want to have a massive subnet like a 1024, right? But we are VLAN'd out, which again is going to be okay, right? Because we are subnetting on, because each one of the subnets that we're on, right, 2, 3, and 4, are in the third octet as opposed to the fourth octet, where the subnet is needed, essentially, right? Because the actual CIDR, which is a /25, is only relevant to the fourth octet. Okay, so what does that mean? It means that when we do our subnets, right, from 0 it goes to 128, and then it goes from 129 to 254. The next subnet would actually be 256, but what I'm talking about is the usable IP address space in between is what we care about. Yeah. Before we move on to the next lot of IP addresses. And for a company, although you can have a lot, it does generally depend on how many IP addresses you have available at the time. But then you could do inter-VLAN routing if the company was to ever expand to 1,000 people on a different subnet, and you'd still be able to get the same level of access anyway. It just means that the IP addressing would be slightly different, but you'd have the same rules, do the inter-VLAN routing on the IP address chain, and you would be fine as long as it's not being used by anywhere else in the company. So I think for our standard design, that looks pretty good. Right, going back to the SSH access stuff. I said public and private key pairs. Now, the one thing in general Cisco you don't really learn is public and private key pairs, which goes to the concept of symmetric and asymmetric encryption keys. Now, in very basic terms, symmetric key is basically the one that you open and close your door with. Very basic. Your private key, on the other hand, is what's called an asymmetric. It's generally asymmetric. Actually, no, I've got that kind of. Sorry, this is asymmetric encryption, right? Yeah, sorry, I've got this wrong. Asymmetric encryption is basically where you have two keys. So if you think about, those really old movies, I think one of them is called War Games, and there's a scene I think in there which, the computers go to war and stuff like that, right? But I think there was this like a simulated scenario involving nuclear. You have your kind of two keys, you put them on at the same time, press the red button, that kind of stuff. And that's basically what asymmetric encryption would be. It's where you put the two keys in, turn them at the same time, up pops the the little red button, and then you go in and you do your stuff. Yeah, I'm not suggesting anything. I just think it's just a nicer way to learn it, and that's the way that I've learned it throughout the years, right? Whereas symmetric encryption is where you have the same key opening and closing a lock. That's called symmetric encryption. Why? Because you have one lock, which is like a padlock, and you open and close it with the same key. Okay? Easy, straightforward. And that's it. That's pretty much it. I can't think of anything else that would impede this design at the moment, but the good news is we spent half an hour going through the pros and cons of our design. I would go with router on a stick, just to be sure. Router on a stick implementation. And there's one other bit that I've forgotten, which is going to be DHCP. Now, why DHCP? Why didn't I pick something else? Well, let's think about this. We have 68 people, and we don't want to be giving them static IP addresses, right? Because there's, we haven't talked about servers or anything like that. So that's another thing we could ask is, well, are there servers which are which need to be statically assigned for this new office, right? Let's assume it's an office, right? For this new office, do we need to have static IP addresses for things to be assigned to? Now, if the answer is no, then it's just a general, it's a general office which has, general facilities which will connect over a VPN or some sort of dark fiber over to the data center. The data center has all that equipment that's needed for them to do intermediary work. This could be things like accessing the NAS, right, if it's co-located, and stuff around, perhaps a firewall to do checks around data transfer, for example. Yeah, that's the sort of thing. Doesn't necessarily mean it'll be in every single situation, but it is something that we take into account. The AD service, for example, which would be on premises, would live in the data center, right? Normally speaking. Now, it could be on premises as well, which would be in the office, but it's kind of a... No, actually, no, it would live in... Sorry, I've got that completely wrong. It would be in the office. There we go. See, it's this... I'm gonna blame this cough. There you go. It would be in the office, right? Because it would be quicker to do the access, right? But it could be, for example, a WSUS server, which would be again, in the office. It could be stuff like that where we need to then assign a private static IP address because we don't want that switching over. If we're doing imaging and then we're saying, right, okay, power cut comes back up, and then we say, right, okay, IP address has changed. Oh, I can't find the WSUS server. Oh dear, TFTP is kind of, not working the way it should do. What do I do? Or even if it's a MDT server, it's like, oh dear, no, I can't find, our file share, and that becomes a problem. So DHCP in this case is fine because we have no servers stated in ticket, so no static IP addresses needed for now. But it would be something that we would clarify on the ticket as we move forward. Yeah, and that goes for anything that we're ambiguous about. Just like, okay, well, do we need this? Okay, well, let's ask, right? Because there's no point in assuming that we know the answers. And there's one person that taught me a very long time ago about a lesson that I'd never forget in my engineering career ever. And I still don't forget it, and I'm out of engineering. Right? The one thing I would say, right, because it was such a good thing, and he was a contractor. He was a contractor. His name was I think his name was Andrew. Andrew something his name was. He used to work for Amazon. He doesn't work for Amazon, and he was a consultant with me back in the day. And he used to say, "Don't assume anything. Don't assume anything." And it's such a brilliant thing to think about when you're coding, when you're doing networking. Don't assume anything. If you're unsure, ask. Pretty much what you said. Pretty much. Great guy, and yeah, really nice guy to work with and learn from. So we'll do DHCP for now. So there's nothing there, and that's relatively what we would do. That's exactly how we would build a network in this case. So yeah, I hope you've enjoyed that. I know it's been a bit long, 36 minutes, but it's worth the detail. It's worth understanding, what the kind of plan would be in that case, what the sort of, implementation plan would be going forward, what would need to be questioned, what the benefit would be to the stakeholders. So that would be like the CTO, it could be the financiers of the company, or it could be the general public itself, the people who are involved in the project. So understanding that perspective, technical and non-technical, how do we communicate with our stakeholders to say, look, this is what we're thinking. Do we need to transfer any data, for example, if we're talking to stores, right? So I did this in retail, and it was a store implementation. What's the type of traffic that needs to come down the pipe, which would be another one. Right, it's good for the ACO. It's good for the ACOs actually. Right? Do we need to? Sorry, needs to go down the pipe. That should say. Is that Active Directory? Is that, does that need to be NAS? So AD, NAS, etc. Right? That's the sort of thing. Now, if you know all that information, then we can commence the design. But in this case, for now, for what we have, this is good enough. Good enough to make a very basic design of what we need to do, what we're thinking about, and how we do the implementation. So these would be the standard notes that we put down, and we would submit forward, and we would also implement our costs. So what are our costs? Cost breakdown for our procurement manager. Yeah, and then by having that, right, in terms of equipment, needed. And then the other one that I'd also put down is access points. Access points. Do we need wireless? Wireless LAN controller. In my case, we did. So in my case, my story was that we needed one wireless LAN controller. We used the Unify series LAN controllers. Wireless LAN controllers, sorry, which is the Wi-Fi ones, because we didn't have access to Meraki. Or even, well, we had Draytech, but Meraki we found out was better, but we were more of a Unify house, and it worked. It worked very well, was very easy to set up in terms of VLAN assignment, and as a result, we could easily implement that back into MPS. So radio space authentication, is that needed? Also, off the network. Is that needed? Is that needed? Radius or tactics? right? How are you authoring to the network? Do we even know? So that's another thing we should be thinking about. And what else should we think about? What else other information should we be thinking about? There was one more and I forgot what it was. I think that should be okay actually. So wireless LAN controllers, TACACs. Oh, port security. That was it. Port security. Port security. Port security. So, do we want to make note of the MAC addresses, right? MAC addresses. MAC addresses. Violations. Do we want to shut down the port? Violations. Age. What's the age timer? Do we need it? Basically, is what I'm trying to say. Right. So that's the other thing, right? Do we need to have what is the security level? Now, in this case, I would say probably not that much. With the most relevant one being manufacturing, because we don't want espionage happening from an attacker on the inside, right? Now, an attacker on the inside, that would be there's a name for it, and the name escapes me. Insider threats. That's it. It'd be called an insider threat. Now, it can happen, and it's one of the more dangerous forms of attack, right? But if we have, for example, MAC address security, it kind of helps because on the laptop we can say, right, if somebody tries to log in with an unauthorized laptop, which can then be further strengthened or enhanced through radius and TACACs, then we can say, right, okay, this person is not authorized on our network and shouldn't be authorized on our network because it's not an authorized laptop from the company, right? It's not necessarily BYOD, which is like bring your own device, but it would be saying that this particular individual is coming in with an unauthorized device, therefore we should not allow them on the network, right? Because we have a policy in place which prevents it from being on the network because it doesn't match a particular MAC address, for example, right? Or it's in the wrong port. And that wrong port would generally be on a desktop, but for a laptop, this kind of environment favors laptops, I would imagine, and probably even some access points. But it's something that we should clarify with the site manager and also the procurement manager to understand what the structure is of the building and where things are going to go. So that's what I did. When I did this, I said, right, okay, to the procurement manager, right, what's the layout of the building? Where are all the access points going to go? Where's the patch panels? Right? Because the patch panels are what's going to be, in real life, that's what you would have. You'd have patch panels. Patch panels would then say, where is the connection for the Ethernet? So you'd say, right, okay, so it's port 1, port 3, port 5, port 7. If it's on the top, you'd have, 2, 4, 6, and 8 on the bottom. Because generally speaking, on a switch, you'd have odd numbers at the top and even numbers at the bottom. And then you say, right, okay, port 1, for example, goes to port, 10 on the patch panel, which goes to port 10 in the real building. Now, the cool thing about it is that if that switch is PoE, right, you can power the access points over PoE, and it would work. Now, cabling is also another problem, right? And data transfer. So cabling and data transfer. And it's one that we actually should keep in mind as engineers is, well, okay, if we have cabling and data transfers, right, what type of cabling would be sufficient? Now, there's no mention of this here. And what do I mean by there's no mention of this? Well, what I'm saying is that sometimes you need a quicker transfer of data. So if I think of manufacturing and engineering, right, and this is like a car company, because it looks very much like a car company in my view. But, I don't know, but we could say it's a car company. So it's for a car company. Yeah. And let's bring this over here in terms of our design. If it's a car company, what is a car company going to be having in terms of a network? So if it's like Formula One, right, they will be pushing out loads and loads of aerodynamic data, right? In the wind tunnel tests, it's going to be stuff like aerodynamics data. What is the stress on a wing, right? On the aerodynamical wing of the the front wing, or perhaps even the rear wing, right? And getting all that data. Now all that data is going to be what, petabytes of data. So there will be a NAS system there. We're not told this, so it's an office for it's an office at this point. So we don't know, but we should ask. We should ask. We should ask. And that goes back to the question of, well, what needs to go down the pipe? Because once we know that, we can optimize the cabling and say, well, okay, if you're pushing out petabytes of data in terms of what's being generated, which will then be used for something like AI, then we need to be able to support 1 terabyte, 1 terabyte peak bandwidth, for example. In that case, we can justify the spend to the procurement manager and then say, right, okay, we probably need like a £5,000 switch or a £1,000 switch, depending on depending on the type of workload that we're trying to. Goodness me. Wow. Depending on the type of workload that we're trying to establish. Yeah. So that allows us then to say, right, okay, if that cabling and that data transfer is set as a particular target for the bandwidth, then we know, okay, we can use an OM3, an OM4, an OM5, do we need OM2, and look at all those cabling standards and say, right, okay, do you want full duplex, do you want half duplex, and that comes into play, and also in terms of the nanometers, because it depends on the distance at that point, as to whether or not we go single mode or multi-mode fiber. Now, single mode, generally speaking, is better on the principle that the distance is longer, and it's a slightly more less dispersed light in terms of the core, because I believe it's a smaller core diameter, from what I remember, and that's the reason why. But we're trying. We have to think about the cost in terms of the company, and in this case, I would say it's perfectly fine to have LC connectors as the most common connectors anyway, and then say, right, we'll do multi-mode, multi-mode, and it's no, it's not dual core. It's not dual core, but it's a multi-mode fiber, right? We just do a multi-mode fiber run, OM4, OM5 directly down, 100 gig, for example, or 200 gig, depends on the aggregation if you use aggregation, and then say, right, okay, as it's all aggregated, then there you go, we can support the bandwidth, and Bob's your uncle, right? Because now everything works and we can justify it. So as long as it's justifiable, then it's fine, and then manager will be off your back. Well, all the stakeholders will be off your back saying, "Oh, why did you want to go and spend 5K?" Well, that's the reason why, and now you have a way of managing it. So that's another thing we should think about is, well, how do we manage this? How do we manage the fleet for updates, firmware, ECT, right? So that's another thing we should be thinking about. Now, how do we manage that? Well, we could use Cisco ACI as a method. We could use Ansible. We could use other things like that to say, right, okay, well, do you want to do network automation? So perhaps we have an Arista fleet. It's Cisco in this case, but Cisco would also have APIs on, the higher switches to say, right, okay, well, we can manage them through this, but it doesn't justify the spend in this case because this is a small network, right? It's only 68 people. So it doesn't really justify the spend of £5,000, which is a small office. Perhaps for a company like McLaren or Aston Martin, in which case then, yeah, this makes sense. But it is something to think about, so we'll put it down there anyway. So yeah, that's pretty much it. I hope you've enjoyed it. It's been pretty interesting, making this sort of design, and I hope you've learned something, and I hope it's helped you in some way. So if you like this kind of content, you want to see more of it, please subscribe to my YouTube channel, and also if you want a bit more from me, this will actually be going into kind of a podcast format soon as well, and this is just a start. You want to see more of this, I'll actually be making a platform where you can actually get more content, for example, like this, where you can get more projects. And project for yourself, where you can then say to employers, look, I actually know what I'm talking about because I can justify the business reason and the engineering reason. And I understand, how to talk to different audiences. So now when you think about it in that terms, who wouldn't want to go on the platform? So that's going to come out soon. But if you're more interested in finding stuff about that, why not contact me directly, right? Because the platform's not out yet, but I'll let you know when it's out. But contact me directly, and I'm more than happy to sort you out in terms of, what's the sort of projects I should be thinking about? What's the sort of things I should be asking the manager? And this will also help you to get interviews as well in the long run, right? Because now you can justify it. Now you have evidence. Now you have a portfolio. Now you have things where you can see the actual benefit and the architecture as to how things work together, which isn't always obvious when you're inside of the organization. But if you think about it this way, through this system, you can say, right, okay, this is the way things fit together. And this is the reason why. So yeah, if you think that, so if that's valuable to you, jump on a call with me, write in the comments, networking, and I'm more than happy to send you more information. All right, I'll see you soon. It's been a fun one. And even ESET, as I'm just about to close the video, has turned around and given us its faithful module update failed. So yeah, thank you very much. Have a good night, wherever you are, morning, evening, afternoon, and I'll see you in the next one.